correlation. All right, last thing here, using a line of fit to model the data, we have 4 steps we're going to follow. Okay, first we're going to make the scatter plot. Then we need to decide if there's a correlation. Can we draw a line through it? And then that line needs to try to fit that data. That's going to show us a correlation, and it's also going to help us make an equation. Okay, so we're going to do one here. Again, we need to make all of these into ordered pairs. Okay, we have weeks and we have sales. This shows the weekly sales of a DVD and the number of weeks since its release. Okay, we need an equation. We need to write an equation in the end. That's our goal. That models DVD sales as a function of the number of weeks since its release. Okay, we need to find a slope and a y-intercept. We're going to use an equation in slope-intercept form here. Okay, so again, we're going to take a minute, label our axis here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, these are weeks down here. This is our x-axis. And let's count by 2's again. 2, 4, 6, 8, 10, 12, 14. Okay, we're just labeling our axis. We need to go up to, looks like 20 is as high as we need to go. This is sales, okay, in millions. So let's go ahead and plot our points. We have 1, 19, plot a point there. We have 2, 15. 3, 13. 4, 11. 5, 10. 6, 8. Okay, a lot of this section is a lot of graphing here. 7, 7. And 8, 5. Okay, and what it asks us to do, remember, back to our steps. Okay, we need to first see if there's a correlation. We're going to draw a line of fit. And what that means is this line needs to try to split these points. We're not connecting the dots. We're drawing a straight line to where approximately half the points are above the line, half are below it. Try to split it the best we can. Okay, again, there'll be some approximation in here. Okay, but if we drew a line roughly through these points, we want about half the lines to be above it, half the points to be above the line, half to be below. Okay, there's some approximation. So we have this line here. This is what we call our line of fit. Now, we need an equation from this line. Okay, so what we need 2 things. We need a y-intercept, we need a slope. Okay, so if we look at this y-axis here, that crosses approximately at 19. If we pick out 2 points on our line, let's pick out the point right here. Okay, see this point right there, and oh, it crosses a coordinate down here as well. Okay, let's use these 2 points. We know that this point down here is the point 8, 4. Okay, 8, 4. This point up here is the point 6, 8. Okay, these are our 2 ordered pairs we're going to use. We need a slope and a y-intercept. Okay, we know how to do this. We've been doing this for a long time. Let's find our slope. Subtract our y-coordinates. So we have 8 minus 4 over 6 minus 8. Okay, and what we get there, we get a negative 4 over a negative 2, which we know simplifies down to a, oh, that's why that's wrong. That should be a positive 4. That simplifies down to a negative 2. Okay, our slope, our m, is a negative 2. Now, y-intercept. Okay, we can look at this graph. If we approximate here, look at where that crosses our y-axis. That's our y-intercept. It crosses about 19. Okay, now we can either do that, we can approximate, or we can plug. We can take 1 point and plug it into point slope formula. Okay, you should get roughly the same answer. So if we see our y-intercept is right here at about 19, that's our b, that's our y-intercept. So let's plug it into our formula. We have y equals mx plus b. M, our slope, is a negative 2x plus our y-intercept, plus 19. Okay, and that's our, approximately, that's our answer. Lines of fit, there's some approximation involved. Okay, but that's our line of fit. Remember, draw a line through the points, roughly half the points above, half the points below. Pick 2 points on the line, find the slope, find where it crosses our y-axis, write it in slope-intercept form, and you have your answer.